Let's have a look at scientific notation. Scientific notation, not scientific number. A scientific notation is being used for numbers that are either really big or very small. Let's have a look how a number like this is being written down to make it. We want to write it down as short as possible. So 8 times 10 raised to the n power. Let's first have a look at this a in front. This a is a number that has to be strictly greater than or equal to 1, but smaller than 10. And that just means the following. If I have my decimal right here, and this is the first spot behind, and then the so and so on, it moves on right there, how many decimal spots I have. This first number, this one right here, that comes in front of this decimal, has to be a digit. Either 1, 2, 3, 4, 5, 6, 7, or 8 or 9. It has to be one of those numbers. It cannot be 11, 12, or 13, or 0. And then the exponent up here, this n, that has to be an integer. That means it can be 1, 2, 3, 4, 5, and so on. It can be also -1, -2, and so on. We have seen in the last section how negative exponents are being dealt with. So if this is a positive exponent, then if I want to write out this number as a normal so to speak, a notation, then I take the decimal and I just move it right n times. This right here would be a very big number. If I have a negative exponent and I want to rewrite this number in regular notation, then I'm going to have to move the decimal to the left n times. And this would be a very small number. So let's have a look just to get used to the idea of what these numbers look like when I write them down in regular notation. So I have 7.4 times 10 to the 5th power. This is really nothing else but multiplication by 10 5 times. So what happens right here is I had 7, 4, 0, 0, 0. I'm just adding a bunch of zeros in the back here. And I know that my decimal used to be right here. But now my decimal has to move to the right exactly 5 times. So first it moves right here. 1, 2, 3, 4, 5. So my decimal will move to this spot right here. And I have the number, what is that? 740,000. Right here is now my decimal. Again, it moved from right here, 1, 2, 3, 4, 5 times into this position. This is the same number as before. Don't get me wrong here. This number and this number is the same number. It's just written in a different form. And you can imagine the more zeros you have in front of the decimal, the longer this right here would get. And this right here, I would just have to add the exponent. Now, what happens if I have a negative exponent? I am writing my 3.2. And I know that my decimal now has to move to the left side. So what I always like to do, I'm just adding a bunch of zeros in front. And now I start moving my decimal. So how many times to the left? 4 times, because this was a -4. 1, 2, 3, 4. Right here it has to be. Now I can just disregard the first 2 zeros. They were not necessary. I only need 1 0 in front of my decimal. So I have the number 0 point, how many zeros? 3. 1, 2, 3. 3, 2. This is a very small number, as you can tell. All right, let's have a look what we are going to do if we compute with these numbers. So computing with scientific notation. We are only going to look at two different operations, multiplication and division in this section. So if I have a number in scientific notation and I multiply it with a second number written in scientific notation, then really what this is, it's just using the rules of exponents. This is why this is the last section where we have discovered and exercised all of the rules for exponents. This is multiplication all the way through, so I'm just simply multiplying the first two numbers and then use the rules for exponent that says 10 raised to the n times 10 raised to the m is just 10 raised to the n plus m. And for division, very similar. I am just going to be looking at these number values in front. I will just take out my calculator, I will divide those ones, and for the factors of 10, I will use my rules of exponents, n minus m, top minus bottom. All right, let's have a look at some. Oh dear, I need my calculator for this, I believe. I left it in my office, so let's have a look. I believe I have something here that I can use. There it is. I don't like to use calculators a lot, but this is one of those instances where it really comes in handy. All right, so let's have a look and let's see what happens here. 5.41 times 10 to the negative 6 multiplied by negative 3.2 times 10 to the negative 8. So what I will have to do here is this. I take 5.41 and I multiply this with a negative 3.2, and this will be the part I need my calculator for. And then I'm going to have times 10 raised to the, well, I have a negative 6 plus a negative 8. And you see, I mentioned earlier that it is helpful to put the parentheses in parentheses, the exponents in parentheses. I was supposed to add these two exponents, and that means back here I'm going to get negative 6 plus negative 8. That will be a negative 14. And now I just have to use my calculator right here. Let's have a look. 5.41, multiply this by 3.2. I will just make this number negative. Negative 17.312. All right. So, are we done? This number now we have to fiddle around a little bit with, because what happened here when I multiplied my first two numbers, the decimal is not in the right spot. The decimal should be right here between the negative 1 and the 7 in order for this number to be still in scientific notation. So I'm going to have to fix this. Here is an easy way how to remember what to do in a case like this. So I have a negative 17.312 times 10 raised to the negative 14. This decimal right here has to move to the left. Well, what operation is doing such thing? If I would take this and I would divide this by 10, that would then move the decimal one spot to the left. But since I have divided this whole expression by 10, I also have to multiply it by 10. Look, what I really did, maybe let me just write it like this. I took this number and I multiplied by 10 over 10. 10 over 10 is nothing else but the number 1. So this multiplication doesn't change anything. What I'm going to do now, I'm going to distribute this in such a way that it will be helpful for me. This division by 10, I'm going to put to the negative 17.312, and the multiplication by 10 I will attach to the back. And what will happen here now is this. This division by 10 moves the decimal into the right spot. And in the back, what I have is 10 raised to the negative 14th times 10 raised to the 1 is negative 14 plus 1. And that means I have a new exponent, and that is times 10 raised to the negative 13. All right. So let's have a look at the second example, division. A negative 3.2 times 10 to the negative 8 divided by 5.41 times 10 to the negative 6. What am I supposed to do? I believe those are the same numbers in scientific notation. The first one was multiplication. Now we're dividing them. So what I just have to do is I take these number values at the beginning and will divide them, and then I'm going to look at the exponents, and I have to use the rules for exponents, which said top minus bottom. Remember to put the parentheses around this, because now it really becomes crucial. Well, the first thing, what do I have? For my calculator, I'm just going to use 3.2 divided by 5.41, because I know the number will be negative. This is a negative, this was, because the numerator was negative, 0.59149. We're just going to leave it with the hundredths times 10 raised to the, what happens with the exponents? Well, this is going to be a negative 8 plus 6. So I have a negative 0.59 times 10 raised to the negative second. All right. Now we still have a little bit of a problem. As you remember maybe from the beginning of today's lecture, this number in front, this digit, this value right here cannot be 0. It has to be a number between 1 and 9. So in other words, the decimal is in the wrong spot. And I'm using basically really the same trick as before. What I'm going to be doing with this number here, I will take this whole number and I will multiply it by 10 over 10. This does not change the number. Multiplication by 1 is still the same. 1 times 4 is still 4. But what I'm going to be doing now is that in this case, this division by 10 now moves to the back part, and the multiplication by 10 is going to go to the front. Hold on, how am I going to do this here so that it looks nice? Let's take this whole thing. Now let's write it down nice. So in other words, multiplication by 10 is going to be attached to this first part, and the division by 10 is going to be attached to the back. Now I'm just following through. Multiplication by 10 moves the decimal to the left, and in the back I have 10 raised to the negative 2 minus 1, which will then give me a negative 5.9 times 10 to the negative third. There is some sort of a table in the book that says if you need to move the decimal right here to the left, you have to subtract 1 from the exponent here, and if you need to move the decimal to the right, you have to add 1 to the exponents. I never really found this very useful to remember. I'm just multiplying and dividing by 10.